Alright, so today we are going to tackle two absolutely essential skill for any program. So that is called testing and debugging. So no matter how carefully we write code, error, or bugs, it has a natural part of the development process, right? So what's the difference between test and debug? So let's say debugging is the process of. Can anyone tell me what is debugging? Like why? What is debugging and what is testing? Come on, guys. All right. Then what's testing then? All right. Finding errors and checking everything. And then what is debugging? All right. Somewhere to somewhat to. Oh, yes, Arpina, like true. So debugging is a process of finding and fixing errors or bugs in your code after you have discovered them. So often because your program crashed or gave an incorrect result. But testing, it is a process of actively trying to find errors. Testing, we are finding errors. So we are testing whether it's going to go wrong or something like that. So it involves running your code with specific inputs, like someone said here, and checking if the inputs are or if the checking the outputs are correct and the way we wanted it to be. So before going, why are these skills so crucial? Because reliability ensures your programs work correctly and consistently. And it also improves maintainability, like well-tested code is easier to change and update with the breaking existing functionality. If something goes wrong, don't break. If it works, don't break. Something like that. So confidence gives you confidence that the code does what it's supposed to. And finding and fixing bugs early is much cheaper and faster than fixing them later in the development or after this cut will create a loss of bad impact and loss of reputation for that company and for the developer as well. So today we look at the common types of error and basic debugging techniques and an intersection to writing simple tests for the Python scripts. Alright. So understanding the type of error is so crucial. So only when we know the what type of error we are finding, so we'll know how to fix that. So first one is syntax error. So these errors in the grammar of your Python code. So the Python interpreter catches this before the program even starts running. Example, misspell keywords or missing colon, missing space, extra spaces, incorrect intention, mismatch parentheses, etc. The Python will usually point to the line where the error is detected. Correct. Let's say, yeah, sure. Meanwhile, I suggest you guys to go through with me because it will make you feel interesting. Just by listening, you can't understand. Sorry. So I want you guys to point it out what went wrong here. Let's say, all right, what type of error is this? I'll write some example I want you guys to point your phone. Mm, so yeah, I gave three things. Someone pointed. All right. Syntax. There are three examples. Give me three things. And I want to know what went wrong here. I know the syntax error, but what went wrong here? All right. All right. Mm-hmm. The first one, the brackets. The second one is the colon. The third one, here, indentation. Exactly. Shit. All right. So if you see syntax error or intention error, carefully pick the line of the Python indicates like if you show the line where it went wrong, and it often like immediately before it, so that for any typos or structural mistake you can correct it out. Okay. So runtime errors. So these errors occur when your program is running. So the syntax error happens before the running of the program. So if like encounters an operation can perform when a runtime error occurs, Python raises called exception. If not handled, the program crashes and will get traced back. So we learned about this handling in try except blocks that are handling exception. So common runtime errors are name errors. So using a variable function name that has not been defined. Usually happens when you miss something like name. Example, I miss ADC, but if I misplace a row D also, name error. And the type error, performing an operation or an inappropriate data. For example, adding a string to an integer, like string hello plus 5. So we even had one example it gave us type error. So type error can only concatenate string, not integer to a string, like string to string, integer to integer, and the value error. So the data type is incorrect, but the value is inappropriate. For example, integer we have like asking input from the user has an integer, but we are getting a string, or we have a list called, let's say we have a list and that has a number, but we are converting that into string, it works. But if you add that, we give an error. The name next is key error. Usually happens when you are working with dictionaries. So trying to access a dictionary key that doesn't exist. So zero division is the most common, like it's the first example we have on. So dividing a number by zero gives zero error. So we even had that example in a exception handling session. While not for error when we had when we this I'm not sure which was the solution. When we were playing with like open clicks in the while playing with dictionary sort of stuff. So trying to open a file that doesn't exist will keep the file not found error. Go through the screen for me once and we'll start with the logic errors. All right. So logic errors, also called as semantic errors. So these are often the trickiest to find. So the program runs without crashing. So when it happens when we are doing some mathematical function. So but it produces incorrect result or behaves any indented, like we don't know the way it should be behaved. The syntax is correct and there are no runtime exceptions and uh, there is no runtime errors, but the underlying logic of your code is flawed. Let's say you're using greater than instead of lesser than for comparison, or you are having incorrect formula in your calculation, something like that. Logic errors require a careful code review, testing with various inputs and debugging techniques to pinpoint. So when speaking of debugging technique, let's move into that. So when your work, like when your code isn't working as expected, you need to debug it. How? Something called the print statements, like the print-driven debugging or something they call the KF-man debugging. So these are simplest and often surprisingly effective technique. Like we insert print statement at the various point and in here could display the values of a variable and check the flow of like execution. If you have a line of code and you want to check if this part working well, this part working well, use a print or to see if a certain block of code are being read or not. So let's write here normal function for taking something like this, say some use some mathematical function. Let's use some string and find. Say we have, I'll write a code first and I'll explain it guys at the end. So it will be better for me to write it fast and explain it once I'm done. Let's assume we expect numbers and we want to double them. Okay. So bug one. What if the item is a string that can be integer? So it will fail, right? What if the item is already a number and integer item is okay? Yeah. So let's introduce the bug for demonstration. All right. Before a bug, let's try to run this code. Then I know, let's say, okay, so what is happening? Okay, now I want to double this. So what type of error this one is? This like anyone? Guys, only when someone responds, I move. Guys, it's a logic error. So I want to double. It will return the value, but it will not give me the output I wanted. So let's cause a typo error for better understanding. Let's say if I want this is a random thing. It won't run. Let's say. Can you even tell me what? Okay, Abhishek. So this is next. So tell me what type of error we can expect. We guys go back to that error handling session they will also. Anyone? Oh yes, silence is no fun. So let's say the unexpected value error. So instead of using an integer and use a string, it will cause a value error. For better handling and use value error. Right? What could be the item? One more what type of error can be. Alright. So we have had a brains to see the state of debugging. So variable before, during, and then after the operation system. So print messages confirm if a certain if condition or made, or the loops are entered, or the value has been correct. So while useful, remember to remove or comment out these debug prints once the issue is fixed, as they can cluster the output. The way it happens when you're using it a console log, something like that. So let's run the code with demo data. I don't hear people. So when a real-time error happens, like exception occurs, and it's not handled, Python plays a trace back. So this is a primary cue. So read it from bottom to top. In the last line tells you the type of execution and error message, and the lines above show you the sequence of code that led to the error, with files name, with line numbers in the code of that line, etc. Any doubt, people? All right. Now you will use a debugger tool from the Python. A debugger is a tool that allows you to step through your code line by line. So it inspects the values of the variables at each step and also set breakpoints to pass and execution specific points. So Python has a built-in debugger called PDP. You can insert using import PDP. You can use like PDP the set trace back into your code where you want to start debugging. Alright guys, I'll show you the command once, go through and we'll start one example for debugging. All right. So first you code PDP. We can't run PDP using this, so we need to have set of backend to run a PDP. So just for conceptual, let's just say we have one example. So range say I want to multiply A to B. Simple. So let's say we suspect an issue around here or want to inspect values. So we start traces here. So execution will pass here and you will enter the PDP debugger. Usually VS Code don't allow you to use debugger, but you can use, you should have a specific backend for that. Let's say we have two intermediates. I'm just writing a random code, no definition here. So let's say now I'm going to say the potentially problematically if we divide intermediate 2 later and with a 0, sorry, intermediate 2, the 0, what will happen? It will give it as an error. Let's say we want to give a warning text because we might know what will happen here. So forcing it to be a non-zero for this example to avoid actual division by 0. Like in real scenario, you'd handle this as a logic error, right? This is how it's gonna. Then we write all the code line by line. And it's something. It's just cut it short. And now, and we want say we are entering a value. That's value 1, value 2, or whatever. So calling a complex function with A, it could A for value, B for value, and C will immediately go to intermediate to 1 instead of 2. This is where error will happen because this is 0 already. So PDP will trace here and take you to PDP debugger mode. So like when PDP stress back is hit, your program passes and you will see PDP prompt in your terminal. So common PDP commands are n is equal to n for next that executes the current line or code to the next line in the current function. And for the else, it step into a functional call if the current line calls a function and C for the continue for execution until the next breakpoint where we have another set trace back. And N for the list and B for the breakpoint and Q for the queue and H for the help. So these command lines we use in terminals. Debuggers are incredibly powerful for understanding complex flow and variable states. So many ideas like VS Code, PHM have graphical debugger, but this VS Code I don't really have because it gave error when I ran. So while debugging fix errors, testing helps prevent them and ensures the code work as intended. The manual testing by running a script with different inputs is okay for small script, but it's not scalable or reliable for big browser projects. So there's something called automated testing. It is writing tests to your code. This is the cornerstone of robust, like a sturdy software development. So Python doctest module, we have a Python doctest module that allows you to run examples embedded within your doc strings. So this is great for simple function and for ensuring your documentation stays in sync with your code. So we'll just for the conceptual, we'll go through that. All right. So let's have a simple code and check. Let's have a basic mathematical calculation for the dot string. So let's say I just want to have one addition. Will be quick. That will have much time here. So this function has two numbers, for example, add 2 through 23, 4, 5, minus 1, 0, and goes on. Right. And now, we'll import the top string. What we're going to do, we will import top test. So dot test runs all the dot tests in the current module. So it prints a summary of tests run and any failures. Let's say result dot test dot test mode. I want it to run here. And there will be your result. There will be two results. Result failed, result attempt, result passed. So we'll just say result failed. Want to know the result which got failed. And how many data, how much. You can also test a specified function. Let's say docstring example, and same thing, and we'll add, say, add global variable declaring or local variable, something like that. Like a shortcut method. Everything pass checks. So let's see, we'll add some failure here. Let's see. I'll add something in between here and make it a different commented. Let's just say uh, So, static one. Trying to add a comment. I don't know what type of edit to play with. Let's just say I'm thinking. No. So this is how dropshipping will go and check one by two, code one by one, and brings the value. So let's say I'll add one more hash here. Maybe this might work. No issues. Any doubt until there, guys? Something one other thing adding here. Okay. So variables. So variables is something that makes the dot string give more detail output. So it prints each step instance and the expected output and the actual output. It is useful for debugging. For example, if we put false, it will return just what went on, not like two tests in one item, two pass, zero fail, nothing like this. Just tell, it will just tell it just got failed. The Verbose tool is helpful when you want to see each test being run, like what happening in the back end of the talk string, especially during development or debugging. Or if you guys have any doubts, let me know. And once I explain how doctors how work on here. The toxic is nothing. It's just like a debugging tool we use. It talks. Just similar, just the way we are just going through. So if anything in between goes wrong, it will check if it's a passing or is it a failing, something like that. For better example, let me come to this one. Let's say we'll do some logic error here, even the command. So let's say write a command. So what teacher returns the sum of A and B. All right. So add of 2 and 3 will give 5, right? So just say we put 6. So this is incorrect on purpose. The correct sum is 5. Maybe this might work. Yeah, it worked. Yeah, for example. So we commented. So this would show failure because it had a logic error. So we gave a wrong example here. So that's how dropstring, like it catches when the commented thing catches like what went wrong, what expected, what should be caught, something like that, based on the function we given. So inside dropstring, the line starting or title has Python interactive shell input. That's why I gave something like that. And the line immediately follows the expected output. All right. So verbose is true, like I explained, to give more detailed outputs. If the actual output of example doesn't match with this output, the upstream reports a failure here. That's how it's a simple concept for more understanding here. Did you understand, Manoj? Exactly. Then let's try keeping it false. See the output. Since there's no much detail here, we're just forcing it to be as a truth. Can see the differences. All right. So a few tips to make testing debugging more effective. Like for debugging, we have to reproduce the bug to understand it, and we have to fix. And for testing, write a small code and test that in that code in well-defined function and classes, and also the debug thing in that. So we want to know what happened, what went wrong. So today we covered the critical topic of debugging and testing, and we even gone through with the inbuilt Python module, one with PDP and this stock string. So effective debugging and thorough testing is what separates a good programmer with a bad programmer. So this because they lead to more robust, reliable, and maintainable code. So any question about debugging techniques and writing tests? So what people do right now, they automate tests, so you can run them easily and frequently before you complete code. Use version control like in Git. So it's incredibly helpful if you want to introduce a bug, or you can easily report a previous working version. Any doubt, people? Or guys, if you don't have any doubt, you can leave. Thank you for attending.